Okay, so we're on the first page of the note packet in section 1.1. And the first thing we're going to look at are some building equation scenarios. My favorite example always is using the U-Haul example. So reading through this, U-Haul is charging $19.95 for the day and 79 cents a mile to run a 10-foot truck. And the total cost to run a 10-foot truck for the day, just the day, can be represented by this equation. U equals, no matter what, you're going to spend $19.95 and then 79 cents a mile. Determine how much it will cost you to rent a 10-foot truck for the day and drive it 75 miles. Notice that the input variable here is M for miles, so I'm going to plug 75 in where I see M. The cost of the U-Haul is represented by the U. I'm going to need to throw this in a calculator to simplify it. After throwing it in a calculator, the result is going to be $79.20. So majority of the cost obviously comes from how many miles you drive. Determine the number of miles you can travel for a total cost of $175. So this time we're looking for M. We know what U is. U represents the cost. So I'm going to still use the same equation, but this time I'm going to plug a number in for U and solve for M. And so the number I'm going to plug in for U is 175. I do this thing whenever I'm solving an equation to keep myself organized, where I put a line right down the equal sign. So I know that whatever I need to do on one side of the equal sign, I also have to do on the other side. In this case, I'm going to need to take away 1995 from both sides. 175, take away 1995. Is 155.05. And then if I want to solve for M, I'm going to divide both sides by 0.79. That's going to give me approximately, so I need to use approximate symbols here, approximately 196.27 miles. And so because we're talking about whole miles, you're probably going to have to pay for 197 because they won't let you just pay for a quarter of a mile. So we're going to say the miles approximately that we can drive are 197. I put a little blip here in the corner describing the difference between an equal symbol and approximately equal symbol. So if you get time to read through that, that brings some clarification. Let's go to the next page. While you're in spring break in Fort Lauderdale, Florida, the cost represented by C in dollars of your taxi ride from the airport to your hotel can be represented by the equation C equals 2.10 plus $2.40 a mile. And then we are assuming that the ride is going to be M miles long. So if they want us to find out how much it would cost to take an 8-mile taxi ride, we would be plugging 8 in for M. And so our equation would look like this. And after putting that in my calculator, I've determined that that ride is going to be $21.30. B, how many miles can you ride if you budget $35 for the taxi? So I'm going to plug 35 in for C, because C represents the cost. 35 equals $2.10 plus $2.40 a mile. And I need to subtract $2.10 for both sides. That will leave me with $32.90. And then if I want to get M alone, I have to divide both sides by $2.40. This is going to give me, for miles, 13.7. Imagining that you are in the taxi cab and you know you have to go 13.7 miles. And this time I'm not going to approximate because you have a budget. It could take you that long. If they would only take you to the nearest mile, then you could afford to go 13 miles. You would not be able to afford to go 14 because you would be 3/10 of a mile short as far as cost is concerned. Let's look at the next example. A small bicycle company is producing high-tech bikes for an international race team, and the company has fixed costs of $5,000 per month for rent, salary, and utilities. For every bike they produce, it costs $755 in materials and other expenses related to that bike. The company can sell each bike for an average price of $1,995, but it can produce a maximum of only 20 bikes per month. So we're going to write an equation for the monthly cost of producing B bikes. So we're going to use C to represent cost, and this says that no matter what, we're going to spend $5,000 because we have to cover rent, salary, and utilities. And then if we are looking at each bike is going to cost $755 in materials. So I'm going to multiply that by B, and this is just representing the costs. So for B, it asks how much does it cost the bike company to produce 20 bikes in a month. I'm going to use that formula we just built, substitute 20 in for B. If I put this in my calculator and simplify it, I would get $20,100. Write an equation for the revenue from selling B bikes. So revenue is just money brought in. We're not considering the costs or anything like that, just where people are paying their bills, we're bringing money in. According to this, we are going to sell these bikes for $1,995. So for every bike, people are sending in $1,995. How much review? Goodness gracious, lots of autocorrect going on here. How much revenue will the bike company make if they sell 10 bikes in a month? So if I were to substitute in 10 for B, then the company would bring in $19,950. That's for selling 10 bikes in a month. So you can imagine if it's 20, it would be double that, and that's pretty good. That's pretty good income. Let's go back, go to the next page. Still looking at the bike scenario. E. Write an equation for the monthly profit the company makes if they produce and sell B bikes. You can assume they will sell all the bikes they make. So remember that the profit is going to be equal to how much they bring in with the revenue minus how much they spent on cost. So we've already got an equation for cost. Remember that the cost is $5,000 plus $755 for every bike. And the revenue is $1,995 per bike. So I need to take these expressions and substitute them in for their variables that we have when we're looking for the profit. So for the revenue, we have 1995B, and for the cost, we have 5,000 plus 755B. We're going to be able to simplify this formula after dealing with the parentheses. If I distribute the positive 1 in front of the first set of parentheses, and I'm going to distribute negative 1 with the second set of parentheses. Notice I distributed that to both of these. I do have some like terms I can combine here. The 1995B take away the 755B will give me a formula of 1,240B minus 5,000. So for every bike we sell, if we plug that number into this formula, we will know actually how much the company is making or losing depending on how many bikes they've sold. So what is the profit of producing and selling 15 bikes in a month? That means that I'm going to use my profit formula and plug 15 in for bikes. And once I put this in my calculator, my profit is going to be $13,600. I'm assuming this is profit because I didn't end up with a negative number, and it's possible to not sell enough bikes to turn a profit, so that's a thing. How many bikes does the company have to produce and sell in a month to make $15,000 in profit? So I'm still using the same profit formula, but I'm going to plug 15,000 in for P, and I am looking to solve for B. So I'm going to start by adding 5,000 to both sides. So if 20,000 equals 1,240B, divide both sides by 1,240. B is going to be 20,000 divided by 1,240, 16.13 bikes. Now this is one of those situations where you can't really sell 0.13 of a bike. So if we want to make $15,000 profit, we're actually going to have to make 17 bikes. If we sold just 16 bikes, we would be under how much profit we made. We would be under 15,000. So 17 is going to have to be our final answer. H, how many bikes does the company have to produce and sell in a month to make $30,000 profit? What I want you to do is I want you to pause the video and complete this question and then come back and compare your answer to mine. Okay, so you're going to have to review and see if you got what I got. I did everything the same as I did in G, except I had a different outcome in mind. I wanted to have $30,000 in profit, and after solving my equation, I should end up with needing to sell 29 bikes to break the threshold of a $30,000 profit. Part of the objectives for this section is to start looking at all kinds of equations and being able to solve for X. And of course, I'm starting off with some really challenging ones. As soon as people see fractions and equations, they get really sketched out. I want you to remember that anytime you have an equation that has fractions in it, you can find a common denominator. In this case, all pieces have to be considered 3, 6, and 1. The common denominator, which is the least common multiple, is going to be 6. Then I'm going to multiply each piece by 6. Each piece. So there's 1, 2, 3 pieces here. I'm going to multiply each piece. So I'm going to say 6 times 2 over 3x plus 6 times 5 over 6 equals 6 times 7. What it's going to enable me to do is cross cancel. So for this first one, remember that even though 6 is a whole number, you can express it as a fraction if you put it over 1, not that we want to right now, but if it helps you visualize that we can cross cancel. The 3 goes into itself once, goes into 6 twice. These 6 cancel. Now I can start multiplying out and writing my equation with no fractions. For instance, 2 times 2 times x is 4x plus 5 equals 42. This has now become a user-friendly thing. I can subtract 5 from both sides. 4x is equal to 37. And then divide both sides by 4. For me, it's okay if you leave your answers improper. I believe that WebAssign won't have an issue with it either. But if they did want us to write this as a mixed number, I know that 4 goes into 37 9 times, because 4 times 9 is 36, with 1 left over. So that 1 that is left over, I'm going to put over my original denominator. So either one of these answers will suffice. Let's look at the next one. Okay, so on the next question, again, we have fractions. So much fun. Maybe not. I'm going to go ahead and distribute over here. 1/4 times x looks like this. 1/4 times 5 looks like this. Then I have the 1/2 x minus 6. My common denominator is going to be 4. So I'm going to multiply each piece by 4. Trying to put this in here. I can cross cancel the 4's here, cross cancel the 4's here. 2 becomes 1. This gives me x plus 5 equals 2x minus 24. And now I can go ahead and finish out my equation. I'm going to subtract x from both sides. This gives me 5 equals x minus 24. And then I'm going to add 24 to both sides, which is going to give me an x value of 29. Who'd known that we would end up with something that was pretty and not a fraction for that one, but we did. C, the last one, this is probably going to be review for you. Anytime you're solving an equation, it's good to be reminded that you should simplify both sides before doing anything with adding or subtracting to start removing stuff. So we have to simplify the left-hand side by distributing our -2. And I have to combine like terms here. 4t combined with a -6.8t is -2.8t. And I can go ahead and add 2.8t to both sides. Notice I'm lining it up under the term that it is like, the term I can combine it with. And then add 17.3 to both sides. So on the left-hand side, I have a positive 3.3. On the right-hand side, I have 7.8t. I'm going to divide both sides by 7.8. Put this in my calculator and see if it gives me anything pretty. Probably won't, but that's okay. 3.3 divided by 7.8 is going to give me 0.423, and I rounded it to 3 spots. So that's going to be my answer for C. For the next page in the notes, what I want you to do is, again, pause the video and do examples 1 and 2 to see if you've got that last part. Okay, so let's look at number 1 together. If I look at all 4 of these numbers, 8, 9, 8, 1, our common denominator is going to be 72, which is 8 times 9. So I'm going to multiply each piece by 72. I want to write everything out neatly because this is one of those times where it does not pay to have messy handwriting. I'm going to cross cancel again, cross cancel for third time. This would give me 27p minus 32 equals 45p plus 504. I'm going to do what I can to move my p's to one side and my numbers to the other side. And my last step would be to divide both sides by 18. In my calculator, I'm going to put negative 536 divided by 18, which is going to give me negative 29.8. Let's look at the second example. If I'm looking again, this one easier than the first one. My common denominator, my least common multiple is going to be 3. So I'm going to multiply each piece by 3. This will give me m plus 4 equals 12. I subtract 4 from both sides. M is equal to 8. That one was a little nicer. The second part of this page, actually, we are solving equations and we are doing all of the inverse actions to make something look a different way. But these ones we call solving for an unknown variable, because if you notice here, I don't have anything to plug in for f, m, or a. What it's asking me to do when it asks me to solve for a, it wants me to rewrite this formula in an equivalent form where it starts with a equals instead of f equals. So if I'm looking at what's with a, m is with a, they're being multiplied. If I want to undo multiplying, I need to divide. So if I divide both sides by m, it cancels it from the right-hand side, and now I have a equals capital F over m, and this is done. A lot of times these look really uncomfortable for people. But really, if you just trust the process and trust what you're doing, that you're doing the right thing, then you should be fine. So number 2, they want us to solve for h. H has 10 with it. They're being multiplied. If I divide both sides by 10, h is equal to capital P over 10. Done. 3 is a little bit more steps. Well, not really, actually. If I'm solving for b, I have something here, a positive thing that's added to b. So if I subtract it from both sides, y minus mx equals b, I have b alone. So that one's done. Number 4 is meant to be confusing, but it really isn't bad. I have to solve for I. One thing I know is that if I do want to get rid of the w squared, I need to divide both sides by w squared, right? K over w squared equals 1/2 I. If I want to get rid of the 1/2, I just have to multiply both sides by the denominator. That will cross cancel the denominator. So I have 2k over w squared equals I. Not as bad as we thought it was going to be. Take a minute and do number 5. You're going to be solving for m, very similar to number 4. This time, maybe I will start by getting rid of the fraction and multiplying both sides by 2. So I have 2k equals mv squared. If I want to get m alone, I have to divide both sides by v squared. M equals 2k divided by v squared. These are usually people's least favorite things to do. So if you're getting through it fine, you're in good shape. If you're struggling, you're not alone. Okay, let's go to the next page. Okay, so we're going to talk about scatter plots. A few different things about scatter plots that are important to know. Scatter plots are meant to analyze data. And so whenever you have a scatter plot, it's a scattering of data points. And contrary to what you might have learned at some point in your childhood, you do not connect the dots when you do scatter plots. Scatter plots are really meant to help you make projections about the future or the past by looking at trends. There's some different types of scatter plots that you could see. I'm just going to draw some examples. Here's one right here. And then I'm going to do one like this. And yours don't have to be perfect, but kind of similar. Here's one here. The more data points you have, the more accurate your scatter plot will be. Here's one here. I'm going to describe these in just a moment. And then I have one like this. Okay, so these are all scatter plots. We would call this first one a strong positive correlation. And that means that this is going uphill if you're looking from left to right, and the points are pretty together and tight to be able to draw a trend line that would show this going uphill. This we would also call a positive correlation. I wouldn't necessarily call this a strong one because the points are spread out a little bit. This next one, notice this one's going downhill, just like the one below this. One of these is strong negative correlation. The other one is a negative correlation, not necessarily a strong one, so we'll just say this is negative. And a correlation is when you see a relationship between two variables. So in this case, all 4 of these show some kind of relationship, and sometimes it's possible to look at 2 different variables and they have nothing to do with each other, and so we would say no correlation right here. No correlation. And that could be a thing that you find whenever you're looking at data, that maybe there isn't a relationship at all. You have to be open to anything you possibly could find out. An eyeball best fit line, also known as a trend line, when you're doing that by hand, usually that is something that one would look at kind of like an opinion. So again, you're not going to connect the dots. You're just kind of drawing a trend line that shows what you are seeing as a trend among the data. So this one has a positive correlation. The second was a negative correlation. I drew a trend line. That's a thing that you usually have to kind of eyeball if you're doing it by hand. You can do it in a calculator, and when you do it in a calculator, it's very scientific. But the human mind really doesn't have the capacity to do things like that perfectly just by eyeballing it. Underneath here, we have a graph that's showing some data points showing how much prize money was made at Wimbledon. The year since 2000, so this is looking at 2000 to 2010. Estimating the total prize money that's won at Wimbledon in 2002, I would find 2002, follow it up and over. It looks like 8 million, so we have to kind of see 1, 2, 3, 4, 5. So every tick mark up the left-hand side is worth 2 million. And so if you go halfway up, that's 1 million. So I would estimate this to be like $8.2 million. An estimation, again, is an estimation. So if you had 8.3 or 8.1, it doesn't necessarily mean that you're wrong. When they're asking you to estimate, they're trying to look for a window of values. The next one, estimate in what year the total prize money at Wimbledon was about 9 million. So 9 million, again, we just decided it was about right here. So I'm going to follow this over and down. That looks like that probably happened in the year 2003. Part of this is not just creating scatter plots, but also being able to look at other people's scatter plots and interpret what they mean. Here's the last page of your notes, and we're looking at a couple different graphs. The first one I'm going to go over with you. The second one you're going to do on your own. So looking at this first one, they're asking us to estimate the y-intercept. Remember, the y-intercept is the place where the line crosses the y-axis. This looks like it's somewhere between -5 and -10. So I will say it looks like it's probably at 0, -8. Whenever you are talking about the y-intercept, you have to write it as an ordered pair. B, estimate the x-intercept, place where this crosses the x-axis. It looks like it's at 30. So I'm going to write that as an ordered pair, 30, 0. The next question on here is asking about estimating the value of x that results in a value of y being -5. So y is -5 here. If I follow this over until I hit my line and follow it up, when x equals 10 is when y equals -5. Estimate the value of x that results in a value of y being -10. That's right here is where y is -10. So I have to follow over until it hits my line, follow it up. It looks like -10. When x is -10, y is -10. Estimate the value of y when x equals 20. So here is where x equals 20. I go down till I hit my line, move that over, see what the y is. The y looks like it is probably -3. Interpreting and finding the missing parts of an ordered pair is basically what you're doing. So take a moment and pause the video. I want you to do the whole second example, and then you can unpause the video to check your answers. So here are the answers that I got for A through E. I'm imagining that nobody has every single answer exactly like mine because we're estimating. And so again, it's one of those things you're kind of trying to guesstimate where something falls in between two numbers. But if you're relatively close, then great. And if you're not, then maybe just take a look at it again and see if you can reverse engineer what you were doing that could be improved. So this is the end of the first video.